To research methods in the second semester, where we will be covering inferential statistics and their applications. Alongside this, we will be using a software program called SPSS, where you guys will learn to run some statistical tests yourselves. So in the last few lectures then, you guys have been learning about descriptive statistics, and you can recap on these by referring to the interactive revision tool which you can find on Moodle. But we can also just have a quick recap now. So, in a nutshell then, descriptive statistics incorporate measures of central tendency, they incorporate measures of dispersion, and it can also incorporate data visualization. And hopefully you guys will remember that all of these things are really important for just summarizing data. So in this flipped lecture video, which will be split into two parts, along with the associated classroom session, we will be introducing the concept of inferential statistics and the p-value, and use these concepts in conjunction with some of the descriptive statistics which you guys have already learned about, to make decisions about what type of inferential statistics we may be able to use. So before we go any further, it may be a good idea just to recap on some of the basics of research, some of the fundamental questions that we ask with regards to research. So first of all, what's the purpose of research? Well, in research, one of the things that we want to do is understand variation in the world around us. More specifically, we want to know what factors influence variation. We do this by making observations and conducting experiments, whereby we're interested in investigating variables and asking questions about how certain variables, which we may usually refer to as an independent variable, are influential on the variation of other variables, which we often refer to as being the dependent variable. Now here it's really important to note that you understand the difference between independent and dependent variables when it comes to running inferential statistics. So basically, all you guys need to remember is that the independent variable is the variable which affects change in the dependent variable. The independent variable we could also refer to as being the explanatory variable, because it explains what's happening in the dependent variable, which we can also refer to as being the response variable. So to flip that back round, the dependent variable, or the response variable, is responding to change in the independent variable, or otherwise known as explanatory. I've been going on about inferential statistics for the last few minutes, but what actually are inferential statistics? Well, in inferential statistics, we use concepts of probability and of chance to test hypotheses about our data in relation to the variables that we're interested in. Now, probability and chance are key terms that we use in statistics, and although their everyday use gives a similar meaning, they are actually slightly different. So, chance is an everyday word used in a situation where we are talking about the likelihood of an event taking place, whereas probability is a precise measurement of that chance. So for example, in inferential statistics, we can talk about the probability of an event occurring by chance or not. Equally important is the term hypothesis, which is basically a proposed explanation made on the basis of limited evidence as a starting point for further investigation. At least this is how we would normally refer to a research hypothesis, or a working hypothesis that we would use throughout a research investigation. And I'm sure you guys covered this earlier in the module. However, in inferential statistics, there are two further types of hypotheses that we use specifically to make conclusions on whether or not there is something significantly influencing the variables in our data for any given statistics test. These two hypotheses are the null hypothesis and the alternative hypothesis. So what are these hypotheses? What is the null hypothesis? Let's start with that, which we could also refer to as being called HO. Well, the null hypothesis in statistics is the concept that the answer to the question you're researching is no. Or in other words, there's no difference, no effect, no correlation, no link, etc., etc., etc. Whereas the alternative hypothesis, also commonly referred to as H1, is the concept that the answer to the question you are researching is yes. So where we might say that there is a difference, there is an effect, there is a correlation, there is a link, etc. Now, it's really important that you kind of try to wrap your heads around these two different types of hypotheses, because they are really important in statistics, particularly when we're running statistics tests in order for us to make proper inferences about them. So by default, statistics tests test the probability that a null hypothesis is true, or that there is nothing particularly interesting influencing our data. But it's when we find a probability score that indicates that some variable actually is having an effect on our data that we can say that something is significant and accept the alternative hypothesis. That's the end of part 1 of this video lecture. Now before moving on to part 2, you can either watch it again if you're not really confident with the concepts discussed so far, or alternatively you could go to the interactive PowerPoint, which has more information on all the concepts discussed so far. After you've done that, please go on to part 2 to learn more about how probability is used in determining hypotheses, where we'll look at the p-value, as well as some other important factors to consider in research and in statistics.